Hi my friends, today we discuss about adaptivity. I prepared an assembly, double click on it. This is the assembly we'll discuss about. As you can see, there is a space between parts, and we'll see how to eliminate this space introducing a tolerance by using adaptivity. This assembly is a part of a former project which I made, and I placed it on CAD. And all the elements here, the components, will be found in a link presented in description of this movie, of this tutorial on YouTube. You look there and you can download all the parts to recreate this assembly and to practice what is adaptivity. Before this, look at the clip where I used this assembly. As you can see, there is a difference in this joint with from the one presented before by adding worm gear. There are two plates, inferior and superior, and the inferior is fixed, grounded, and the superior is moved due to rotating the worms. Two worms are enough for making this movement, parallel movement of the superior plate, usable in creating movies and so on. Now we are back to the adaptivity problem. We want to create adaptivity between this element, which is called oscillating fork, and this part, which is called a rod. To do this, we double click on the oscillating fork. We go to the extrusion. This is the part and this is the extrusion. Right click here and properties to add to the properties of this feature, not to this part, to this very feature. What property parameters? I want the parameter of this extrude to be controlled from outside the part, specifically from the assembly. Yes, I make available to the assembly environment this parameter. What is this? This is the dimension between these faces, because the extrude was created using a middle sketch and a plane here, and with symmetrical evolution. Now this is 10, and we want to be adapted on the rod to be 8 or 8 plus tolerance. OK, you see it appears here some marks. This is mark with two arrows, blue and red, are the sign of adaptivity. I can see this again because I right click here, and you see adaptive is added, selected, checked here. I go out from the part, coming back to the assembly, and I am careful to add this adaptivity also to the part, not only to a feature of that part. The sign is present also here in the browser. Now, since we modify this part to be adaptive, I can introduce a constraint between this face and this face with an offset of, say, 0.2 millimeters, and apply. You look here, apply. The extrude was modified, and there is a space here, 0.1 here and 0.1 here. The parameter was modified because of this adaptivity. I finished this. I go now to other thing which is related to adaptivity. In fact, I make this transparent. You see here I can use Alt-T. This part now is transparent, and I see that the rod, this is the rod, has no hole here. Now I want to create a hole in the rod copied from the hole in the oscillating fork. To do this, I double click on the rod. This is the part what I want to change. Click here and select sketch, F Foxtrot 5 to go the view back, and now I project, be careful, the hole on the rod. Finish sketch, extrude. What? Now I edit this part. Yes, I select this circle from the face of the rod. Then I select cut, and all the way is the hole. OK. Now I can change also the aspect of the surface to be like this one, titanium polished. I go back from but let's see here. The rod now has two marks of adaptivity. One is the extrusion, a feature of this part, this feature, the hole, and also the part itself. Return to the assembly, return from transparent, and now we know that there is a hole in the rod. The same you can make to the other end of this, but let me show how it works. You see, like a universal joint. In Romanian, cuplaj cardanic. Cuplaj cardanic. Cardan is a universal joint. I want to mention that this face was constrained to be parallel with this face, because that two plates which are present in the movie are not here, the plates, and I simulate this by adding this constraint at 180 degrees and also the constraint of parallel this with this. Yes, and now they move parallel one to each other. Look, on this direction, and also on the other direction. They are parallel. Yes? Good. Now we want to add a new part in this assembly, because as you saw, there is no shaft between the two. I make this transparent and you cannot see here a shaft. I want to create this shaft to be to connect that two parts. I do this by using the tool Create. Let me do it without previous explanation. I create in place a component, giving it a name, shaft, selecting a template. This is a part, yes, not an assembly, a part. Okay, and now I have to show the plane where the first sketch of the new part is placed. That plane I want to be the midplane of this part, oscillating fork. This part is this one, the one which is adaptive, not the one which is not adaptive. So I go to this one, I select origin, and I select this plane. Now start the sketch. The sketch must be in this very plane, and here I want to have the previous. Here I also project in the new sketch of a new part. I also project the circle of the hole in the oscillating fork and not in the rod. Yes, this is the face of oscillating fork, this of the fork, because I'll change the dimension in the fork, and you will see that everything is changed, the hole in the rod and the new shaft. I have this sketch, finish sketch, extrude. This is the only closed area in this new sketch. I generate this symmetrical. The diameter is from the oscillating fork, and the dimension is let's try 30. Oh, 30 is very good. 30 millimeters, both to both directions. Okay, this is a new part of steel. Its general aspect is gunmetal, antique. This face has the other aspect of titanium polished, because we want to be all the parts in a same fashion. Return from my new part. The new part is here inside, but I forgot to create chamfers. Double click on it. You see here, this is the new part, which is adaptive, because I created using environment of this assembly. Double click again here, double click here, select 0.5 to both ends. Okay, and now I really finished the part. I finish the assembly. I make F6 to see all. You see the part is here. This is the first instance of this, and now I eliminate transparency to finish all. But I re-transparent that now, because I want to change the diameter of the hole in the oscillating part and to see effects on the other parts. Double click on the part which I change. I go to the hole. This is the hole, an extrusion. There is a sketch with diameter of 8. If you see here, 8 millimeters is the diameter in the oscillating fork, because I added oscillating fork number 2. Double click on the sketch, double click on the 8, I put 6, finish sketch. Now the hole is 6 millimeters diameter, and I am in the part environment. I go back to the assembly, and then we'll see together that not only the diameter of the oscillating fork is changed, but also the shaft and the hole in the rod. Look here. Why? Because they are adaptive. You see, the same diameter. I want to change this, the shaft to make transparent, Alt T, and the hole in the rod is the same. Yes, this is adaptivity on 3 elements, 3 components of this assembly. 1, 2, 3. I make them back transparent, and everything is okay. You have to make the same thing to the other end. Yes, by downloading the parts from the description of this tutorial. you have also the drawing at the beginning to create the parts if you like. And now let's create a new part. We start by creating a new assembly where we place two parts. Part number 4. This is one part in my library of parts, which will be created during the time. I have a collection of 100 parts, and I started to model that part, but 94 is somewhere at the end of this process. Another is the part 97, placed here, escape. Now I have to align them. This is fixed and this is mobile. I apply insert, choosing this circle and the exterior circle here. Okay, F6 isometric, and we see we can rotate only, but first let's select the new constraint and to put 80 millimeters a distance between these two parts. To eliminate this degree of freedom, I use angle first solution between these two faces. Okay, and now I cannot move this part. Good. Now we create the new part, an adaptive one. You see here nothing is adaptive. You will see soon that this part is adaptive. We create a name, connection piece, okay, and we select template. Okay, now I have to select a face, a planar face, like this, where I intend to create the part. This is the face, and I can project the geometry of this flange or flange in my new sketch. I can do this, or these lines in yellow appear if in the general options at the sketch this auto project edges for sketch creation and edit, this option is checked here. Be careful. Once we have a contour, we can apply extrude of say 12 millimeters. Okay. The new part can have many features. Another one can be created by selecting this other flange and to project the contour on the sketch. Why? To extrude. I extrude this. What is the dimension? 12. Okay. Now I make not visible these two planes, and I move on. If you look to the browser, you can see a lot of adaptive elements. All these features and the part itself, of course, because we project sketches from other parts to our one. Our part now is connection piece. Yes. Before I start, I have to create two sketches. One on this face. I change lines and I create a circle. As you can see on this face, also select and construct another circle. Between these two circles I create a loft, a new tool which needs to select two sketches. I prefer to select them from here. One is this, you see here, sections. Sketch 3 is the first, sketch 4 is the second. Click here and something is suggested here. I go to conditions, I select the second, 90 degrees and weight 1. Weight is the power of the string, and you can see that I can force the tangent to be at 90 degrees from the face on the other faces, and very strong, not a small angle but 90 degrees. Good. Okay, I have to create another loft, but cutting this last feature, choosing the interior circle, real one. This is a real circle here, I don't need a sketch, and this one also real, to connect the features, and again choosing this tangent and this tangency. Okay, now you can see this new part. I will apply a material, rubber with the aspect version 1.1, and we have this part. Good. This is a new part in my assembly. Return, and now I can change something. Very fine thing to change is this distance of 80 millimeters. I only selected this constraint, and I write here, say 60 instead of 80, and please look to this, what happens when I tap enter. Wow, this is really interesting. The rubber is modified. I can put another value here, double click now. 120, why not? And I have a long connecting piece. What you say? This is an assembly with a part very easy to modify. Remember the value 130. I can go here, I look to 130 and I change it to 87, and when I press enter here we see the modified. This is adaptive. Yes, this part is adaptive. You can create it directly in an assembly like any other part, not only adaptive parts. Okay, look carefully to these important notes. Bye bye.